digital forensics, at least in India, it's a little emerging term. And the goal of computer forensics is to actually explain the current state of a digital artifact. Normally, digital forensics is used in terms of computer crimes, and normally it is related to a legal perspective. And it has actually, or it explains the scientific way or technical, detailed, structured way to explain things. And the scope of analysis normally is can be a simple information retrieval to reconstructing a series of events. Means we have an incident, we have a case, what happened, the details about these events, and then forensics guy's job is to reconstruct those events. And timelines basically has got a very good role in this. So I'll just take you, while reading Law General, actually I got a chance to look at this. These are like two cases basically. And 2011, death of Michael Jackson and Conrad Murray, that was a lady actually. These cases, the forensic timeline evidences actually helped to prove the guilt. And the role of timelines has given even enhanced capabilities to the law enforcement. And in corporate environment, intellectual property theft cases are more likely, and very, you can say, obvious questions those are asked to the forensicators is what data is involved, what was there in those secret and confidential files, can we prove that anything was taken out from this computer, and who did it? It's the very obvious question which will be asked. And in similar to that, malware hacks or intrusion cases, these are the similar questions like where was the attacker's code, how did they get inside our network, how did they get in, and what did they do or what did they take out from our network. So these are the intrusions cases which can come to a forensic analyst. I am going to talk about 5 different cases in real detail about approach and artifacts which we can talk about. But before that, I thought I'll just role of timeline analysis. This technique is not very new, it's old, but then there are a lot of changes happened in this technique, and it's a great starting point for an analysis. Normally open investigations can actually help as a starting point to create timelines. And as we said, event sequence, whenever or whatever happens sequentially in a correct story actually has to be done. So timelines can definitely help you creating an event sequence. Then it actually helps you to create a chronology to map suspect's action between offense. For example, like there is a USB device or a guy who walks in using a USB and plugs in his USB into a computer. He copies down files from that, and then he copies those files into the USB and deletes his data from his desktop. But then these sequence actually has got some actions done by the suspect. So we can, using timelines, we can map those actions with actual offense, what he did, like secret and confidential files. If he copies, we can actually map those. And obviously, like the new investigation techniques will involve digital events because a lot of IT tools and IT environment is there. So it involves digital events. So there are basically 2 approaches. One is the kitchen sink and the granular approach. I'm going to spend more time on these approaches, how to explain, how to actually approach the timelines. And moving further, let's look at the timeline steps. Very simple steps, like what you have is normally a digital forensic guy will have raw data, a lot of images around, or maybe a single image, memory dump. There are a lot of data sources like network dump, PCAP dump and all. So you have all raw data, and then what you do is you can have an intermediate formats and events. Those events are actually, there can be anchor points. I will discuss those in detail. And then using those formats, intermediate formats and events, you build an event sequence. So at a particular time what happened, after that what happened, after that what happens. And when you look at that in a sequence, you will have a context what could have happened, like a story, like USB a device case, which we will actually discuss in detail. And then analysis basically is to actually know that like filtering, you have huge data, so analysis techniques is the techniques which will help building the event sequence. And once the analysis is done, actually it's the way to present it. So the presentation should be effective enough to be accepted in the courts. So presentation is also an important part when it comes to a digital investigation. So this picture is all about, like, for a forensicator, what happens is he looks at dead bodies or skeletons, and he has to bring actual body, or he needs to actually explain the data about the actual body. So I'll just put this picture. So let's look at the timeline basics. This table I have taken it from the sleuth kit, and we know that there are a lot of file systems like ext2, ext3 file systems, FAT file systems, NTFS file systems. So every file system interprets its time representations in a different manner. So this table actually, you can say, creates a formula. You have M, A, C, B as the attributes to it. So how to remember those? It's like a very simple formula. M is equal to a modification time. Means in NTFS, whenever there is a file which is modified, you can have this M attribute added. Access time. So whenever there is a file which is being accessed, is actually A time. Whenever there is a change, this basically attribute, or this basically timestamp, is not available. When you look at file properties in your regular computer, you will not get this. This has to be done using forensic tools. And there is one more terminology called as burst time. So starting from NTFS file systems onwards, we have a file created time. A FAT system doesn't have it, and in ext3 you have a separate times called as deleted times. So this is burst time. So I thought you'll just try and remember this. So there are different formats altogether, like 64-bit file time, 32-bit NICs, epoch time, 128-bit system time, and there are strings. Like 64-bit file time is normally a 232-bit binary format, which uses actual information which is stored. So registry values actually uses, and a lot of applications uses 64-bit file times. 32-bit NICs epoch time actually is used by the events and the XML type of binary files. 128-bit system time is actually Windows Vista, and above all new operating systems uses 128-bit system time. It has got a lot of data available, like date, then months, and even till milliseconds. Actually, it has got different values added to it as a 128-bit length key. And a lot of applications normally uses their own ways to capture timestamps, like a string. So it is represented here. Along with that, we need to understand about the interpretations, like file system. The FAT file system actually uses the local time. Means whenever you have a machine which is used in India, so the local time of the machine will be used here. And there is a reference to that. Means it actually refers any file for the time from 1st January 1980. That's actually the year when the file system was actually evolved. And in ext2, ext3 file systems, actually they refer to the epoch time, and their reference is 1st second since 1st January 1970. It's like obvious the time that particular file system has got evolved. And NTFS file systems basically uses the UTC time. Now this has got a standard structure, and there is a very interesting reference value here is 100 nanoseconds since January 1st, 1601. And there is a very good article, if you are interested knowing about this, why Windows or NTFS file system and above file systems uses this particular reference. There is a very good interesting article. So I would encourage actually you guys look at that. It has got a digital meaning basically. It's all about time. Means what happens is, as I said earlier, forensigators need to look at skeletons and create the real story. Like here, this is a picture in black and white, and then he has to create images in color picture, which is like a fact or the true story. What happens is, in times, as we seen earlier, there are different time formats, there are different interpretations, lot of file systems, different file systems look at timestamps in a different way. There's no actual standard which is defined by a standard authorized body to know about timelines. And that's where forensic analyst can actually be fooled, or it actually can, even events can be misinterpreted. So it's up to the knowledge of forensic analyst to take care of these timestamps, how those the data or the timestamps which he has captured, he has to actually know in detail. And we are going to talk about timelines and the artifacts, actual timestamps, how we can actually take out in detail. So let's do an approach. So before, as we've seen, there is no standard. So let's look at approach. There are two approaches basically. One is the everything approach, means the kitchen sink. So what you do is you have an investigation in hand, and then you have, like, say 5 computers for an investigation. You have a lot of network data. You have a lot of data sources like web servers, web logs, and a lot of logs are available for that particular case. Then what you do is you actually dump all that data, extract the timestamps, and create a single snapshot of that particular, so that what happens is you will know what was happening around all the computers, network, and every aspect of it. But then it can be a huge, like say, consider an example, you have 120 gigabytes of hard disk to analyze. Then the timestamps, only the file system metadata can be about like 1 or 2 GBs. So it's a huge data to handle. So kitchen sink approach gives you everything or the clear picture of what was happening on the event. But then this may not be practically feasible to analyze the 3 gigabytes of data, or they are the lines basically, they are the times. So there is another approach called minimum approach, where like say for example, again I'll take the USB devices. So you have a case of only the USB activity, so you don't have to look at actual all the file metadatas, but what you can do is you can actually look at the setup API.log, you can look at the registry logs, so you can pinpoint the activities and you can pinpoint the logs, and then it has less information, so you have like a contextual information, and then you can build a timeline around that. I'll actually give you more details on that. There is actually one more approach called as hybrid approach, where you create a kitchen sink and then you will review it. In my video demonstration, I'll try and give you a review tool preview. Next, have you heard about time stomping or attribute magic? Do you know there are things like you can, I know obviously, like you can change your timestamp, or you can change dates. Many of us have done already backdated things, right? You would change the date of your system. What happens is these tools basically can change the timestamp. So what happens is when you change something in the file system, then it actually creates a confusion or complicates the story. And these anti-forensic tools, there are automated ways to do it, like time stomping. In 2005, Black Hat, it was pretty much demonstrated that using an automated tool, you can change the timestamps. I'm going to actually give you an example of how in real life the time stomping was done. But here is the catch. Actually, these anti-forensic tools don't modify all the timestamps. If you are a really professional investigator and if you have curiosity to go into each and every artifacts, for example, I'll tell you there are 8 timestamps for a single file in NTFS file system. And this is only about the file. So if you have a file opened, modified, and then maybe deleted, you have almost more than 60 timestamps. So all these tools, time stomping tools, cannot modify everything. So, but then it's up to the investigator, and then I will actually give you more details when we look at the NTFS file systems. So not every anti-forensic tool can actually modify all the timestamps. So let's look at the timeline creations. Before I actually talk about building the timelines, I thought to put a 5-field format. This has been actually described really well by Harlan Kavi, who is the writer and author of a lot of forensic books, registry books, and this actually I would like to thank Harlan for reviewing my presentation here, what you're looking at. And this 5-field format is basically a normalized time. So all the times, whatever you have different interpretations, you have different time formats, then you normalize to a single, like say every time is normalized into a UTC or your own reference. So normalized times for all events, everything, and then you have data sources, like say multiple computers or multiple data sources, like you find out the master file table, you have IDS IPS logs, you have network logs. So a lot of data sources, then host, as well as if you add users and users activities, like using registry analysis, you can actually map users, like from SIDs in Windows format or the domain format, you can really map what was the user logged in. So these fields will, when you put it in your timeline, creates a context or creates a detailed information about an event. And then when you look at like say 5, 6 events, then probably you'll come to know that what was happening really. I'll take you through a real-time scenario of that. So to make this discussion more interesting, I thought I'll just put it like cases. These are all hypothetical cases. It has no relevance, no practical evidence. I'm not talking against any companies. Even the opinion or whatever it is, it does not reflect my employer's opinion. It's all my own. So intellectual property theft, basically the case, this has been discussed earlier also, like USB device. A guy walks in with a USB. He actually connects his USB. He copies secret and confidential files from the network share, and then he copies those secret and confidential files into a USB drive, and then he deletes those files. As obvious, like he don't want to actually keep those files in his machine, and then he walks out. So to approach this case, there are 3 major areas involved, like the network share where actual confidential information was stored, and then the desktop and the USB device. So there are artifacts, and to analyze such a case, actually the desktop is the main system that all activities happened, and there are artifacts like USB key identification, first and last time insertion, user identification, the drive letter. So when you connect USB drives, the operating system actually assigns a drive letter to USB device. So you can find out in the registry, you can find out device drive letter and the volume name also. Say a lot of people has got their own volume names on the removable storage media. So those volume names also you can find it out, and then you can pinpoint to a particular USB device. And even there are a lot of like event logs, and these artifacts we are going to analyze in detail. So to approach this case, creating a timeline in a contextual manner will definitely help. Looking at the next case, obviously it's again for a manufacturing company. There is some unusual activity. It's always there. I feel suspicious. Somebody is actually getting inside. My computer doesn't work well. In this year's SANS Digital Forensics and Incident Response poster, actually there is a very good stepped approach which is described in SANS. So I would encourage you go ahead and look at the SANS poster for this year. You will find more information to approach such kind of cases like malware cases. And then there are a lot of artifacts. So structured analysis will definitely help. And timeline plays a very important role in such cases. There is one more interesting case is about like financial website. And here what happened was a fraud online transaction was discovered, and then Apache web server logs were acting abnormal, like the file logs were having a lot of code details or entries which normal logs doesn't have. And then there was suspicion of SQL injection or cross-accepting or things which Lava or Prasanna do normally in their day-to-day life. So there might be a possibility of attack on the web server. But then being a financial transaction and being a fraud financial transaction, they don't do it for a kind of like malicious activity. But this is a malicious activity. So if it is identified as a malicious activity, when creating timelines, because we have the exact transaction, valid transaction IDs, you have application logs, and you can do actually create a timeline based on that anchor point. When you have a valid transaction ID, and then there are definitely like database logs, network dumps, and then creating that, obviously you can create a very good investigative report out of it. There is one more case which I would like to talk about, is the unauthorized access case. This was actually with secure telecom company, and the organization was outsourced. And in this scenario, what was happening was one fine day, someone with the administrative rights actually logs into a portal where the data was sensitive, and then he deletes all the data. So in this case, and the data was important, and brilliant chap, he actually even disabled the backups 3 days before he deleted the data. So there was no backup available. But then to approach these kind of cases is again time of an activity or time of a suspect's action actually plays a very important role. And then these are evident enough. Like say to approach this case, the date of data deletion and how he is deleted. If it is a web application, he has to write a HTTP post query. Normally that's how you actually run some commands remotely. And that's how we can find out, and creating timelines will give you the exact scenario of what was happened at a particular point in time. There's one more interesting case which I would like to talk about, is the email investigation. And this organization, actually what was happening was there was a guy who was with some intent, he was trying to harass someone. And then the same kind of conversation, he was chaining it to a different set of people. Then investigation came in actually to know that who was the originator, or when this content, this sensitive content getting harassment for a person, how is got originated. Then these emails actually has to be put in a time sequence, and these emails normally has got headers, and those headers will have different timestamps, because all the servers email, whenever it passes through entire email server chain, every header there will be a timestamp added, and then you have to normalize that. And timeline analysis even helps to handle such kind of cases also. So from here, we will actually take a deep dive into technical analysis. So whatever artifacts which we have discussed, like these cases and those artifacts, let's look at how you can do it. So the first step of creating timelines is you have a raw data. So raw data, what you can do is you have an image, encase image maybe, or a DD image, or any of the images which you can forensically acquire. And then after doing that, you can actually get those file system metadata. And then here, actually, I have used Harlan's, I have used actually Phyllis, there is a sleuthkit tool to parse the image metadata. You can do it even doing the master file tables. You can do, you can take the same information using different other tools also. I have used this tool, and then you can create a body file.txt. So now body file.txt will have all the timestamps, but they are not human readable. So what you have to do is you have to use one more tool to actually convert this body file into a human readable tool, when you can have actual events created out of file system. And then moving further, actually, let's talk about the master file table. And in Windows, basically, it has got a master file table. Master file table has got a lot of attributes, and as I was talking about, so you can have a Perl script, mft.pl. This is again written by Harlan Kavi. It's available on public. All tools, whatever I am going to use here or I have used here, are all open source tools. I haven't used any commercial tool here. So mft.pl actually takes down the master file table entries and it'll put into a text file. And this is how, like, that's what I was talking about, 8 timestamps. In master file table, there are 2 standard attributes. They are like standard information and the file name. So here if you see, created, last modified, the MF3 entry modified, and last access, the MACB representation, if you remember, you can just look at that. And this, for a single file, the both attributes will store timestamps. And standard information may be modified, but then you cannot modify the file name. And when you, because this is actually being used by the Windows operating system API itself. So, and it will be very difficult, as you've seen, the interpretation for NTFS file systems is the 100th nanosecond. So you have to have only a time window between the 100th nanosecond to modify this in the operating system. So you cannot, there are no known tools who can modify this standard file name. And then when you compare those, you will find out that there was something. So, time stomping. I'll take you, this is an example of time stomping. What is happening here is like the upper portion, this is actually like, now you can relate the MACB, right? So the upper portion is the standard information table attribute for the same file. These, the output here is for the same files, rpc call.exe. And then if you look at this portion, there is a date. M date and C date are different. And then if you look at the red window, for rpc call.exe, the timestamps are same. Even directly looking at the timestamps, you can know that there is something fishy. That means there are some time stomping happened on this rpc call.exe just to confuse the forensic analyst. But then if you look at the standard file name also, it takes efforts to look at these attributes from the file system. But then you can definitely look at the exact fact about a file. And then this, if you add this value to your timelines, you will have the exact time. Along with this, actually, you need to remember like some of the rules. Like when you copy files from FAT16 to NTFS, or when you move files from FAT16 to FAT16 or FAT16 to NTFS, or reverse, like from NTFS to FAT16, because USB activities normally will have, USBs will have FAT16 file system, and then your machines may have NTFS. So whenever there is a file copy and file move, how Windows represents those, like normally, I'll take you a small example, like FAT16 to NTFS, when you copy a file, there is no change. But then FAT16 to NTFS move will have the modified date and the creation date changed into the attributes. Similar to that file properties, you have folder table, which has a lot of file changes, like when you move a file, when you copy a file, when you access a file, when you modify a file. And what changes happens to the MACB attributes will actually have that. Then there are Windows artifacts, basically. Windows artifacts like the event timestamps. Event timestamps, again, a binary file which stores a lot of information in events, and Windows 7, the newer version of Windows, will have an XML version of it. And this particular event pass.exe, actually what it does is it actually parses the Windows events and it creates events from there. And whatever I'm doing here is I'm just capturing the timestamps. And then you can have like registries, registry in config SAM files, or you can have software files. There are a lot of registry hives, and then timestamps we can actually take out from the Windows registry directly. And then we can put it into a text file. so that we can have a complete timeline created. There are prefetch and superfetch. Actually, in newer versions of Windows, starting from NTFS file systems, has got this particular binary format. There is another file to speed up the application. They are creating a prefetch and superfetch files, and these superfetch files basically will actually have interesting information. Like there is a setup layout.ini. This is again a binary file format. It has got information about files which are run, and so you have a malicious application. You can look at the prefetch files and you can find out what time this particular application was actually run. And again, as I said, there are 8 timestamps to find out. So along with that, these prefetch files has got loaded DLLs. So say for example, mmc.exe, there is somebody who is actually modifying some administrative work on the machine. If the mmc.exe, it might have held a lot of DLLs, but then prefetch file will have only that particular module or that particular area of DLLs loaded. So you can find out within MMC what was used. So that actually creates a context when you look at the timelines. Recycle bin, it's an interesting story, like when a file is deleted in Windows file system. So it has got timestamps. Again, even deleted files talk about times. Restore points, whenever there is an application, like say for example Java was installed. So what happens is Windows again will create a restore point. Then that's an interesting area to look at, because there might be a malicious Java which was loaded into your Windows, and then there is a restore point, and then you can look at the timestamps when this was happening. Along with that, there are like shortcut keys. Whenever you open file, Windows creates shortcuts, and again these shortcut files again will have timestamps associated with it. So you can actually look at those shortcut files, and it has got path as well as the timestamps associated with it. So all these artifacts, what you can do is you can actually parse it, and then you create a timeline.csv. It's a, again, comma separated value. It's an Excel sheet. It's very easy to actually analyze. So all the timestamps, all artifacts, you can put all together and create a single timeline.csv. Apart from these, whatever we discussed were the traditional methods to do it. Now, you can extend the timelines. You can look at the Windows Live Memory timestamps. In 2010, actually, I got a chance to give my learnings in Club Hack 2010 about Windows Memory Forensics. So in Live Memory, using volatility framework, actually there is a very good framework written in open source to analyze Windows memory or the RAM. And from RAM, what you can look at is like, these are the timestamps again, time created, time exited. So whenever even say advanced persistent thread or a file which is only resident in RAM, even we can look at timestamps of that file when it was created. And last year, actually, there's a lady, Jamie Levy. She wrote a Python script for, and it's a plugin for volatility basically. What it does is actually it creates a timeliner. It puts all together what all happening was there inside the RAM, and then it creates a timeline. So this Python script is actually will create a timeline from the RAM. You can furthermore extend these two web servers, like IIS will have WC3 formats, and there is a marker called fields. These fields will have again, like say, date and time. So the time associated with it, again the logs will, it has got timestamps. Even from Apache, there is a script to epoch body file conversion, and then you can look at the timelines from Apache logs. And in SANS, there is a very good, interesting case study. I would encourage you go and look at the forensic blogs of SANS. And then this case study is talking about web server intrusion. And then this actually uses a very good, it's a magic tool basically. This is the same tool I'm going to use it in my demonstration video. Just like IIS or IE. The Internet Explorer, and Internet Explorer has got a binary file called index.dat, and index.dat has got a very good structure like header, and there are a lot of hash values. And those hash values, if you look at it, has got very good, interesting information. And there are normally two, for a single URL, there are two timestamps which are stored in different index.dats. One is the default, and again inside a user index in the IE history, there is again one more index.dat. So you can look at and you can relate for a single URL two different timestamps which are talking about, and then you can find out what browser was doing at a particular point in time. Firefox uses a database called SQL, some MySQL database, and these integer values, like if you see the table called Mozilla Moz_spaces, it has got an ID file, and this ID actually relates to the history visits. So these tables, these are the two different tables where Mozilla stores its information, and then when you relate those tables, you can find out timestamps associated with it, and then you can have history visits and places analyzed from a client, Mozilla client. Even Google Chrome uses SQL database, and there are a lot of queries. This is actually out in the public. This is in the wiki actually. I've just thought I'll just put it here. So you can run queries to know about Chrome activities or Chrome database, and you can find out, like again in Chrome there are visits URLs, and then the integer values like urls.visit is equal to visits.url in this particular ID file. So the integer values from here built and relationship when and what browser was doing, and a particular time you can have visits, you can have URLs, and then even if there is any download which was happening at a particular time, then at the same time you can have a complete visibility what browser was doing at a particular time. And then in your timeline, you can definitely jot down suspects actions, like say there was a web server accessed, and then there was some JavaScript launched, there was some file in question was modified. So these sequences you can build it from your timeline through these browser security artifacts. There is one more area which you can look at for the timelines is flash cookies. Flash cookies, all the applications now use the local shared objects because it's browser independent. This is also called as flash cookies, and a lot of developers love this section where they can store a lot of information, and then it's a browser independent. So things will be like very similar when a user changes its place, or there is a lot of information. So LSO file structure is basically a binary file. Again, it has first 16-bit, and this particular first 16-bit is actually a header, and then it has got a object name which is UTF-8 encoded, and the payload encoded is an AMF or action message format. And it has got very interesting attribute like object called date, and this is 10 bytes information which associated with the exact date and time. You can parse this LSOs and you can extend it to your timeline. They'll give you even what was happening or additional data source from flash cookies. Furthermore, extending file timelines to antivirus logs. Say antivirus, there was some activity scanning by antivirus and some findings were found out. Then you can put those antivirus logs or ISA logs or even firewall logs. So these ISA logs, even you can actually copy them, put it in an Excel, even text file, and then you can add these timestamps into your timeline. Along with that, what you can do is you can have like firewall logs. So timelines will be created around that, and then again, network is again one more area to look at, like TCP dump or Wireshark. You know what was happening on the network, and then you have a packet dump. So even if you look at this, actually a Wireshark stores timestamps. So those timestamps also you can add it in your timeline, and then it gives you a network picture. Say for an example like web server attack which I was talking about. These particular, even the network dumps will help you what was the activity which was happening from outside. So even network can build you, give you times. So it's time for demonstration. I have time? 3 or 4 minutes. Okay. Let me just try and run. Patrick Olson. This is the guy who actually wrote this.
What we're going to discuss here in this video is how to extract master file table out of an image. The other day I went ahead and compromised a system in my lab with some malware that I got from malwaredomainlist.com, and now I'm going to go ahead and show you how to extract the master file table so that we can take a look at it, and I'll actually show you where the malware resides after my system was infected. So what we're going to go ahead and do, as you're familiar with the system in my lab with some malware that I got from malwaredomainlist.com, and now I'm going to go ahead and show you how to extract the master file table so that we can take a look at it, and I'll actually show you where the malware resides after my system was infected. So what we're going to go ahead and do, as you're familiar with the prior video where we used MMLS, so I'm just going to navigate out to where I have my USB hard drive connected, where I actually have that image loaded to. So what we're going to do here is we're trying to calculate the offset, so I can use one of the tools within SleuthKit called iCat. So what we're going to do here, like I showed you before, we're going to echo, and we're going to go 512 times, and then we're going to go 2048. There we go. There's 1,048,576. So what we're going to do, let me just clear this real quick. So I'm going to go ahead and run iCat against that image that I have, and what we're going to do here is actually extract the master file table right now. So go ahead and do image type, raw, file system, NTFS, because it's an NTFS. This is the offset 2048. We got that actually from MMLS. Then we're going to navigate here to the image. And then what we're doing here is we're going to set an inode of 0, which actually corresponds to, well, inode is the index node, and the index node or inode 0 actually relates to the master file table. So essentially we're just saying to iCat, hey, go in here at offset 2048, which is our NTFS file system, look at this image and pull out, or open this image up and pull out the file that resides at the index node 0. And then what we're going to do is go ahead and append this to vid. We'll just call it vid4 because this is the video 4, and we'll just name it .mft. Go ahead and let that run. Alrighty, so let's make sure vid4. Yeah. Okay. So there we go. vid4 mft. There it is. So go ahead and clear this for you. What we're going to go ahead and do next is fire up a log to time. Oops. Log to timeline. Go mft. And what we're going to do, vid4 mft. We're going to write it timeline.csv. So what we're going to do here is actually parse the MFT timeline, and we're going to write it, which is the -w to timeline.csv. And this is going to take a while. I'll go ahead and run the command, but I actually have it already done on my system, and I'll go ahead and show you that. So let's just go ahead and execute this command. It's going to go ahead and give me a warning because I didn't specify a specific time zone. I'm in Korea. It's going to default to the local time zone that I have on the system, which is KST. So it's essentially right now it's loading the output file to the CSV. It's writing it to the specific system. What I'm going to do is go ahead and switch over to my Mac. Right now I'm in a virtual environment. That file is quite large, and it has a tendency to lock up this VMware image. So I'm going to go ahead and do that now. Oops. Okay, so here's, I'll just stop it here. Actually, so this was a kitchen sink approach where you have an automated tool. You have an image, or even you can have multiple images, and you can create Excel sheets or the CSVs around that, and then you can analyze those. But the file sizes will be very huge. So I got a chance to actually have another video which was created by David Knights. He is a forensic manager for KPMG, and in SANS 360 he has developed a very good tool to review big files, big CSV files. You have like say 5 GB CSV files. This particular tool, I'm not going to run the video. I know these guys will kill me, and obviously like, you want to have your drinks probably. Now, so this tool actually gives you a very good methodology. This is a binary which he has written, and there are a lot of filtering. There are a lot of views to look at the timelines in a particular fashion. Like say, for example, for USBs, like you can narrow down your entire timeline to a particular date and time. As we see here, like the rows, number of rows will be filtered. And there are a lot of activities which you can do. You can have filtering with the dates. You can have filtering with source and types and all. Even there are a lot of other functionalities. This video is also out. The video which I had played earlier is also available. There are 5 different videos created by Patrick Olson which are available on the YouTube if you want to look at them. And then it creates like highlights. It creates tags. So this gives a very interesting way to narrow down your timelines. And then I'll just I'll take you the final section of this discussion. There's one more actually, like once you have done the analysis, actually you need to present it. And in codes, you need to have facts. And then they are easily understandable by people. So you can use Excel sheets, Excel macros, and you can really pinpoint what is the evident activity which was around. So this is again one representation. There is one more widget called, it's a graphical tool, say a day before of incident and day after incident and what was happening. So this is actually a representation of entire events, and this is a graphical method to represent your timelines. Splunk is very good tool. It has got other functionalities also, like zoom in, zoom out. You can do a lot of additional activities using logs, and then using Splunk again you can represent the timelines. And for Mac lovers, actually BDocs is a very good tool. It's a 3-dimensional tool to look at timelines. And there is a tapestry. It's a database. There is a very interesting paper out there for tapestry database. And using this database again gives you more functionality, more flexibility. Okay, there's some issue. All right. So as we seen earlier, we had a case. Now what we did was like there were 3 anchor points: USB device, user identifications, and file operations. Like there was a USB device involved, then there was some user which was using it, and then now file operations. He opened those files, copied those files, or deleted those files. So your report with the timeline can give the exact information about USB inserted at what time, what date, what was the drive letter, who was the user. Then the file operations like file opened, file copied, file deleted, and the shortcuts, like all the artifacts now you know. So this is the representation of your case in a report. So I'll not talk about this, just try and look at it. This is an unauthorized case again. These are the web application like anchor points. And then again your report will look like this, like HTTP post, data deleted, firewall logs. Even you can pinpoint to a source IP address, and that's it actually. So in a summary, actually I tried to create a timeline for you. There was a macro which I was running in between when I was creating the, sorry, I think there's
So I think in a summary, what you can do is you can create timelines very easily in an automated way. And then I would like to thank these people. Actually, they have contributed, and I am just a user of their technology or their techniques here. I would like to put their credits to them: Rob Lee, Harlan Kavi, Kristen Johnson. Actually, he wrote the log to timeline tool, and David Knights, the review tool which we were actually looking at. Then we'll stop.